Alrighty, we are on to inverse functions. That's the last operation that we're doing with functions, and it just happens to be one of my favorite math topics ever. So I get really excited about this lesson because it's so cool, and it all boils down to this. Inverse functions, if you need to know anything, it's that you need to switch x and y. So cool. So that doesn't matter if it's a table, if it's a graph, or an equation. If you want to find the inverse, switch x and y. Okay? So let's go ahead and take a look at it. I'm going to start with the easiest one first, which is the table. So I just want to point out right here that the notation for inverse has a -1 on it. You can say f of -1 of x if you want. So let me say that again. F of -1 of x. You don't say f -1x. That means I'll multiply. That's not what we're doing here. Or you can just say f inverse. So if you see the -1, just f inverse. Okay? Alrighty. So let's go ahead and get started. This is how cool it is. You have a function, this f function. You need to switch x and y. All you're going to do is take your x's and put them in the y column for the inverse. Then you take your y's, which are these, and then you put them in the x column. Boom, done. Isn't that so cool? So let's see what it's going to look like on a graph then. Okay? Here we have this graph. What we're going to do is just identify some key points. I recommend 5. It's not always practical or feasible, but sometimes we cut off the graph too soon if we don't use 5 points, so we should use 5 points. All right, so this is my f of x graph. So I'm just going to take a table and make a table from those points on that graph, because if I get the table from the graph, then I can switch x and y and get the inverse points and plot those. So super easy, super fast. So I always like to start on the left side of my graph because it's least to greatest. So that's -2, -8, -1, -1. Then it's 0, 0, 1, 1, and 2, 8. So what do we do now? We are just going to switch x and y. So cool. We don't even really get into these inverses that deep, but if you progress in math, it gets even cooler. So hopefully you'll get to see that at some point if you wish. All right, -8, -2 is here, -1. It's okay. Remember, sometimes they are going to overlap. We're not in Math 1 anymore where everything tends to work out perfect. So this is our inverse graph right here. Can you kind of see how they just switched x and y so it went in the opposite direction? Pretty cool. All right, now we're going to move over here to the equation, which tends to be the more challenging one. But really, guys, all we're doing is switching x and y. Studying, and then we have to do our equation math to solve for y. Okay, so what I want you to do first is just go ahead and block that out and write y instead of f of x, because it just keeps us nice and easy. And then instead of writing y to find the inverse, give it a try, switch the x and the y. So all I'm switching is the letter, not the exponent, not anything else. What does step 2 say? Solve for y. Okay, so we need to solve for y. Here is the y, just the y, nothing else. So in order to do that, I'm going to add 5 to both sides. Because 5 and x are not like terms, I'm just going to write them horizontally next to each other. Again, still trying to get that y by itself. So what I'm going to do next is divide by 2. And that's going to undo the 2 that's in front of it. Okay, so now I have x plus 5 over 2 equals y squared. All right, still trying to get that y by itself, but that pesky exponent of 2 is in the way. How do we reverse a square? With a square root. Be careful, no bunny killers here. So you need to put the plus or minus on the side opposite the y. So from here, I'm going to rearrange things a little bit, and I'm going to get y equals plus or minus square root x plus 5 over 2. And that ends up equaling the inverse because we got the y by itself. So all you need to remember is that you need to change back to function notation. Okay, so if you notice at the top, give me a second, right here, it was function notation, so you need to be able to change it back to function notation. If it just said y equals, then you would want to put a -1 on that y, and you wouldn't have to worry about changing it back, but you would still need the -1 because that -1 says I'm the inverse. Okay, so there's those guys right there. Next, we're going to move on to some practice problems. So let's go ahead and look over here. Example 3, determine the inverse of the following functions. We've got this, no problem. Step 1, we got to switch x and y, but before we can do that, we're going to go ahead and just rename f of x as y. You don't have to color code these, but it's kind of fun, and it makes you see the steps that you changed. So when you refer back to it, you'll see it. So first thing we're going to do is add 7. Again, x and 7 are not like terms, so we just write them next to each other. So now what I'm going to do is cube root, because that's going to undo that exponent. Don't need to worry about the plus or minus because it's an odd root. 3 is an odd number, so I don't need to worry about that. The y is still not by itself, so I'm going to subtract 1. And I'm going to keep in mind that that -1 does not go under the radical because it never has been under a radical. So it's not a like term. And then my last step is to make it the inverse notation. So function notation, I don't care if you put that inverse, this part, on the left or the right, but most math people will put it on the left. Okay, next one, we're doing the same thing. Looks a little interesting, and you're going to see that it brings back something from a previous chapter. Because math's cool that way. So what I'm going to do first, what's cool about inverses? You switch x and y for everything. So here I am. But remember, my job is now to solve for y, which is up there. So how do I get the y out of the exponent? This is chapter 10 all over again, logarithms, okay? So I'm going to go log base 4 to the left, log base 4 to the right. I'm going to show you guys something on the side just because I think some of you are still struggling with this. And so I'm okay with using a little math trick to help you out here. Okay, so give me a second. I'll come back and do that. But what I want you to see here is that this log base 4 undoes that exponential base 4, and then what I end up with is log base 4 of x equals y. And you're like, am I done? How do I know if I'm done? Remember, you have to solve for y. This y is by itself, so the only other thing I need to do is change it back to function notation. And if you can see, I already made a mistake there because they didn't name my function f, they named it g. So I need to be careful with that and not be lazy. Yes, you will get marked down for not doing that. So pay attention, okay? It's like misspelling a word in English. Like, they're still gonna mark you down if you make a spelling error, even if they know what you mean, okay? So what I wanted to show you is if you are still having a hard time with taking log of both sides, and you see it's an exponential, you can do the log situation that we did when we were converting from exponential to log. So we're going to a log. You still have to know that you're going to a log. So you're going to write log base 4. So log base 4 of x equals y. So you can see that L shape and get there too. And then just again, of course, change it to function notation with the right function. Okay, let's go do the easy ones now. Now all we have to do is find the inverse. I'm going to start here with C, because what's super cool about inverse and why does Miss Wolken nerd out about them? You just switch X and Y. So what I'm going to do right now is change all these. Put all the Y's in the X spot and put all the X's in the Y spot. This is f of X. This is the inverse. Awesome sauce. Okay, let's go do our graphs. What is it about graphs? We just have to make those tables, okay, so that we can switch X and Y. So pick your 5 key points. If you're like, how are you picking them, Miss Wolken? Well, these all tend to be our parent functions. Maybe they shifted a little, but as long as they show up in the corners of the boxes, then they should be good points. So this is my f of x function, labeling it at the end just because that's always good practice, and we need to know which one is which, so you do need to label. So negative 1, 4 is that first point, 0, 1, 1, 0, 2, 1, and then that last point looks like it's 3, 4. And then to graph the inverse graph, super easy. All I'm going to do is switch all those coordinates. Don't do anything else. Just switch the whole line of x's and the whole line of y's, and then plot those points. 4, negative 1, 1, 0, 0, 1. Looks like you might be doing it wrong because you've landed on 2 points, but trust me, you haven't. You'll see it in a second. 1, 2. Oops. I knew I did something wrong there. And then 4, 3. And you can see that it is a sideways parabola. Okay, let's do this guy right here. So we have our f of x. And I'm going to label that one f of x. And then xy. And then I'm going to have my inverse, xy. And then pick some key points here. So I see this one, and this one, but you always want to make sure you have a negative unless it's a square root, because you can't take square roots of negatives. So I'm just going to pick that one. I know it's not on the corner of a box, but I also know I need a negative, so I'm going to pick the easiest one to my eyeball. Maybe you can notice that this graph is an exponential. In fact, it's y equals 2 to the x because of how these are going up. You don't need to know that, but it's good to make connections. And then I'm going to switch x and y. And then I'm going to go ahead and plot those points. So 1/2, negative 1 is there. Then we have 1, 0, 2, 1, and 4, 2. And you'll notice that this side of the graph is coasting along the x-axis. So if this is an inverse, it should coast along the y-axis because we switch x and y, okay? Also, you should notice that this is in the shape of a logarithm, the pink graph, because exponentials and logarithms are reverses, aka inverses of each other. All right, let's go check out this apply and see what we're gonna do here. So this one says, use the table to find the indicated values, and they give us a nice little example right there. So let's go ahead and take a look at it. They say, find g of f of 1, okay? So what I want you to know for this problem is that the x's go to both the f and the g function. This is the y's for the g function right here. And then this is the y's, sorry, that's the y's for the f function. And then this is the y's for the g function right there, okay? So these highlighted ones are the outputs. And then this right here, the x's are the inputs. Again, just keep on coming back to that idea of inputs, output for f and output for g, okay? So this is X and this is a Y and this is a Y. They just are lazy and didn't want to draw the extra column, okay? So let's see, this example says to find G of F of 1. So first we have to find F of 1. So we're gonna go over here. The input is 1, and what's the output in the F column? That's -1, so you can see that right there. Now they're saying, take that -1 that you just got and plug it into the G function. So now the input is -1, which is here, and then what's the pink output, or what's the G output, and it's -2, okay? So we will erase that so we can see if we can do these. So we have F of G of 3. Okay, so go to G of 3, always start inside the parentheses. So the input is 3. What do we get as the output? 0. So then we get F of 0, which means now we are on the blue because it's starting with F. So F of 0, the input is 0, and we want to know the output for the F function, and that's just 3. So that's our answer for that one. Okay, again, I'm going to go ahead and erase those colors so they don't get lost. Oops. All right, so let's do that. Moving on back to this. So the first one that we have here is F of 2. So we know the input is -2 and it's asking for the output. So that's going to be 2. So we have G of 2, and then we go to the input is 2, but I want the answer here. So that's going to be -8. Okay, so that equals -8. Isn't that cool? You can do multiple. It can be like G of F of H of 0. We only have 2 functions, so we can't do that. But if you want to challenge yourself, you can go for that. So F of 0. So heading back over to this one, the input is 0. So if I go to 0, which is here, the input on the F part is 3. So that means G of 3. And now I'm switching over to an input of 3, but I'm bypassing the F to get what the answer is in the G column, and it's 0. This question says, do the graphs F of X and G of X ever intersect each other, and how do you know? So if you're noticing, this problem right here is not about inverses. This problem is relating to the first part of the lesson, which was about functions adding and subtracting and multiplying and dividing. So this says, do they ever cross each other? So when do graphs cross each other? Let's start there. Graphs cross when they hit the same point, right? Okay. If they hit the same point, then the coordinates of that point for the first graph and the coordinates for the point on the second graph will be exactly the same. So what we need to do is take a look at our table and see the x coordinates we don't have to worry about because they're the same for both graphs. But what we want to look at is the y coordinates, and we want to look and see, is there a place where either of the numbers are the same? So this y is different from this y. This y is different from this y. This y is different from this y. Whoa, whoa, whoa. Here we have the point on the F graph is 1, -1. And then on the G graph, the same input and output values are there too. So when you're asked, do the graphs cross? You would say yes, at 1, -1. And if that was too much thinking for you, just plot the points and see if they cross. It's super easy. You can plot both graphs to see if they cross. Okay? This one right here says to find the missing values. Oh my goodness, I love this one so much. Okay? So this one is combining the earlier part and the after part and making sure that we got it all together. So what does this right here say? This says f of something, and then it's going to equal 8. So what you want to think about is this is the output and this is the input, which means that this is the x value and that's the y value. So what they're really asking you on the f graph, so the f graph is this guy, oops, on this guy, it says, where is there a y value of 8? So y's of 8 are here. So I'm going to look over. Look right here. Oh my goodness, there's actually 2. And right there. So it is 3 and -3. Okay. The next one says G inverse of 5. Well, first of all, what you need to recognize on here is that you do not have the inverse graph for G. All you have for G is this right here, which is the original graph, right? So in the original graph for G of X, you would have the input being X and the output being Y, yeah? But when you want to do the inverse, you switch X and Y. So really what we're looking at is the Y coordinate here for the G graph, because we're not looking at the original G, we're looking at the inverse G. So let's go to that G graph and figure out when the height is 5. So instead of saying G of -1 of 5, what we're really saying is, oops, the same thing that we just said in the last one, which is this, right? The original graph, which is what we're given, compared to the inverse graph. So with inverse graphs, your outputs become inputs and your inputs become outputs. Your x's become y's and your y's become x's. So if they tell you that you're starting with the inverse and they put a 5 next to it, you know that on the original graph, that's actually a y value, okay? So what number does that happen at? The answer is 0. Okay? F of -1. From here, I think they get pretty easy. We started with probably the most 2 difficult ones, so hopefully you'll be okay with these. But this one right here just says straight and forward, find me f of -1. So I'm going to go to the input of -1, and I'm going to look for the y value, and this just so happens to be at 0. So that point is -1, 0. All right, let's do f. It says f of 2 plus g of 2. So I'm going to zoom in on this graph, even though I'm not going to be able to write. F of 2 plus g of 2. So my input is 2. So here's that. And g of 2 here is g of 2. Same exact spot, right? So that f of 2 is got a height of 3. The input is 2, the output is the y value, so it's 3 minus g of 2. The input is 2, the output is 3, so that equals 0. Alrighty, let's go ahead and look at f of x times g of x equals 0, and f of x minus g of x equals 0. So first of all, I just want to show you guys on D, if you just add g of x to the other side, this question is just asking you where do the 2 graphs equal each other. So that's basically just saying where do the 2 graphs intersect, right? And we kind of just did a problem like that. So where do the 2 graphs intersect? And you can see it's right here. They've actually got 2 points of intersection, that one and that one, right? So this one is saying, where do they intersect? It's going to be at x equals -3 and at x equals 2. Okay, we already know that they're going to be equal in their y values, so we don't have to worry about that. Okay, this E one's a little trickier, but we'll be okay. This is the zero product property, ZPP, because we're multiplying. So f of x equals 0 and g of x equals 0. So that's saying, what do you get when you plug in x and your output is 0? So your y is 0. So this is saying this for each of these, right? So look on your graph. We'll start with the f function. Where is the y value 0? Excuse me. It actually happens in two places because it happens, here's the height of 0 and here's the height of 0. So for that one, it's going to be -1 and 1. And then for the other graph, where does it equal 0? And it's right there. So x equals -1, 1, and x equals 5. Okay, that's it for now.